Okay, so then with all the expectations set right up front, very clearly, let's jump into the actual technical details of the content. Let's start with the classes. Can somebody say what is classes in C++? Can somebody think of it by themselves and formulate the concept of classes in their mind? You must have seen classes, the concept of classes also in your programming 1 and programming 2 um, um, classes before you took this data structure class. If you are with FIU since beginning, if you have transferred from other universities like Miami-Dade to FIU, then I'm not sure what courses you have taken there in your previous undergrad classes. But then somewhere, if you would have touched the concept of classes, that remains same for even for C++. Basically, classes is a concept where we want to group the objects that have similar nature into one package. And then once we create this package, we declare like we have objects from this classes, and then we use the whatever we defined inside this package again and again. So let's give in real life, let's try to relate it with a real life example, right? So all of you in our class, in our this COP 3530 class, each one of you is a different student. You have different background, you have different understanding, and basically each one of you are personally different from each other, but still you have something in common. That is, you all are here to learn more about data structures, correct? So that's something that common characteristic is something that grouped you into a same class. That's exactly what we want to do with classes in programming or classes in C++. We have different objects, the objects that have common characteristics, we want to group them together as members of a same class. So classes in C++ can contain two main items within them. Can anybody recall what are these two main items? I'll give you a minute, actually 30 seconds to recall. C++ classes can contain, first is data items, and second, it can contain functions. Data items are variables that you always use in your any program, right? Now, I think we do not need to go into what's the role of variables in the program, and you all are well versed with that. That's what I'm expecting. And even functions. I mean, I don't think we need to go to that one more layer down to nail down the definition of functions and what they are. By this time, you should be well aware of, okay, what are functions in programming? And given that level of your knowledge, what C++ classes contains is functions and data items such as variables. For example, let's look at this class time24. So here we see that we have two data items, right? Hours and minutes. These both are data items. And we have two functions, even this is a data item. And we have two functions, which is operation at time and we have operation duration. So these two are functions in this class. What we want this class to do is take these variables of hours and minutes and do something for us, right? So for example, this add time function, it it's taking an argument 50 as its input. This 50 is a time. So what we are doing is it has some ongoing time, which can be the clock time of your system. And what we are saying it is add this much time to that, whatever you have. So what we are seeing it as, if it's 9:30 a.m., then we are asking it to add. So if we consider that our clock system is from 0 to 23 hours, and in any clock system, we always have 60 minutes, right? 0 to 59. So then in that case, with this operation add time, what we want to do is add 50 to this 9:30. Adding that, now come on, common sense, you know that 9:30 plus 50 minutes will give you 10:20. That will be your result time, but that this is what we want that function to do. We have this another function called duration, where we are giving two time, right? Where we are saying, so if this is the wall time or the clock time of the system at that time, then we are giving it an input of t, where t is just this, where we didn't have space to write, but let's say that t is 16 hours, 15 minutes. Then what we are saying it is that find the duration between this time t and the clock time. So what it's doing is t minus this item subtracted by this item, right? So that's equal to the duration between these two times is nothing but 1 hour, 30 minutes. So this is the function in which we put two data members, hours and minutes, and we put this is the class in which we put two data members, hours and minutes, and two functions, add time and duration. In the world of coding, in the world of C++ programming, how we use class is the class declaration is we need to use the name class, and then we give our class name. Class name can be anything that you like. In this case, we can give a class name of time 24, right? That was our class name, our class name previously in the example that we discussed over here. And then what are these things? Can anybody recall what are those things? What are they called? They are your visibility labels. If you have thought that, then congratulations, you are correct. Are we missing any visibility label? Is there anything else? Again, as I said, that you are expected to know C++, so this is just a revision and you're trying to recall something that you already know. So that's where I'll be asking some questions like this, and you are expected to recall things from what you know. We have public visibility label, we have private visibility label. Do we have anything else in C++? If you are thinking protected, then yoo-hoo, you are correct. So we have public visibility label, private visibility label, and we have one more, which is protected. It's very easy to understand the concept of each of this and differentiation between these visibility labels. As you know, as the name says public, the content within whatever you have within this visibility label, all the data items and the functions that you declare declare as public members of the class, those are visible to everything else in the class. So if you have an object, you can access all these data items and all these functions from object in the globe of whole program. Then you have private data members, and you have private private member functions. These private data members and private member functions, they have the scope of their visibility is only limited to the member functions. So if you are accessing a data item, if you want to access a data item that's declared here within the private label, then you need to ensure that those data items are accessed from the functions only of this class. So those functions could be described as a public over here, and then you can access this data item from this calling from this function. So the function needs to be a member function in order to access something that's declared as private. Protected, the concept of protected is nothing but you can access things. It's similar to private, but it's a bit more liberal compared to private. So not only the functions of this class, no, so not only the member functions of this class can access things that are labeled as protected, but also the classes that are inherited from this class can access the things that are labeled as protected. Again, if inherited is a new word or is something that does not ring the bell of a clear concept in your mind, go back to the textbook. ForeignTop has a short or long, I don't remember that exactly, but it has a clear explanation of inheritance and abstraction. You can refer to that chapter and read about inheritance and abstraction in object-oriented language. So logically, if you think, public is something like you have a phone and everybody knows your password. Okay, so that's something like a public. Private is something like you have a phone and nobody on this earth knows your password apart from you. It's only you and you who can unlock this phone. Protected is something like, hey, you have a phone, you know the password, maybe your girlfriend or a boyfriend also knows this password, right? So then there is a limited set of people who knows this password, or maybe your parents know this password, maybe your kids know this password, so something like that. But not everybody knows this password. So that's the difference between public, private, and protected. Very easy to remember. Just remember your phone and remember who knows its password. So if we look at the code for class time 24, I have put together an example over here where we have some data items and some member functions under the public label, and we have some data items and some member functions under the private label. So remember what I said, what I just explained about how to access the data members and member functions of things that are labeled as private versus how we can access the data members and member functions of things that are labeled as public. Recalling that, what do you think will be answering these two blanks? So if the label is public, then these data items and member functions are accessible to what of time 24 class. So what is the accessibility permission for public? I think most of you should get this right, okay? Because we already talked about that just like a minute back. So if it's labeled as public, then it's accessible to any object or objects inside or outside of class 24, time 24. So public says it's accessible to any object. Doesn't matter if it's inside or outside the scope of class, whatever class we are dealing with. So here we are dealing with class time 24. If it's private, then it's accessible to only the member functions of the class. So the class is time 24 here. So it's, if it's private, it's accessible to only member functions. Of a given class, of class time 24. Okay, moving forward. We have another nice keywords or the concepts to recall. So given again some class, like for example, class time 24 over here, what is the group of functions and data within the same, like grouping, the concept of grouping the functions and the data members within the same class called in any object-oriented language or object-oriented programming. This concept that a class has data items and a class also has member functions is called something. What is that? Encapsulation, correct. Again, if you don't know what is encapsulation at all, or if you don't understand by this line, then please read in the textbook. Encapsulate or encapsulation. That's the concept of grouping the data members and member functions both into the same, under the roof of that same class, grouping things that have similar characteristics in one package. What is the concept of hiding the implementation details from the user of a class called? So we do like these details about what is public, what is private, what is protected, how these things can be used, those things the end user of the program doesn't need to be much aware of the in-depth details about this. The user is just bothered of, okay, how to take advantage of the things that's served by this package. So this package is class and the user doesn't need to be bothered of integrate details of how this package is formed or how the class is formed. What is that concept of hiding the information details from user known as? Again, this is a concept of object-oriented programming languages. That is also true for C++, but not only for C++, it's applied in Java, in any other program, object-oriented programming. Information hiding. This concept is called information hiding, and C++ also uses the same concept of information hiding. Okay. So then let's look at an example of a class where here in this example, definitely you will have your libraries to include, your namespace to include. We are using std namespace. And then as you see that we have two classes over here, class A and class B. Particularly, we are looking at some of the concept that deals with multiple classes in the same program. So let's see that you have two classes in the same program, class A and class B. And what we are doing inside this class is we have no private label. We just have a public label in both the class. In both these public label has this public function, which is void print. And inside void print, we are just printing hello from whichever class it is. So from class A, we are printing hello from class A. From class B, we are printing hello from class B. This way of defining the function in the class itself is inline functions, right? Again, this should ring a bell, the word inline functions. If not, please read about it more in the textbook. I'm just writing short form for the function. So this is inline function, but you cannot write all the functions as inline. And that's why we have scope resolution operator, which we use by this symbol. This should ring bell. So most of the program, we just declare things within the class, but we define those functions by using the scope resolution operator later outside after closing the class. But if it's just one line, then we can use it as inline function. As you see over here, we are defining what the function print does within the class itself. So that's an example of inline function. What we are doing here in the main is we are declaring an object one, obj1 of class A. Then we are declaring object 2 of class B. And after that, after we have objects for both of our classes, so to use the things or the functionalities within the class, you have to have an object in your main function for that. So once we have that handle of objects for both of our class, then we call this function print of both of these class. So what do you think when you run this program? What do you think it would print? So a couple of questions over here. If you have not triggered this question by yourself, then let me trigger them to you. So here we have two classes in the same program that has the same name, that has a member function with exactly the same name, print. First, is this allowed? Or is this some kind of violation that will result into some kind of error when you execute? Second, we also have two objects over here, right? Two different objects. And these two different objects are calling the same function. So whatever output you get, will it be correct? What you expect? So what you expect here is hello from A and then hello from B, two lines as your output. But because we are having two different objects calling the same function, will it be able to go back and trace to what we want? And will the output be what we expect, or will it be something different from what we expect? Like, for example, just hello from A, or hello from B, hello from B. Or for somebody who is even one level advanced in thinking your horses of mind, might be thinking that here you have two objects that are different, obj1 and obj2, they are two different names. Let's see what happens if you have both the objects of same name. For example, A obj and B obj. If you have something like this, rather than differentiation of 1 and 2, is that allowed? This is the level of details that I was talking about, that you should be conceptually clear in sense of how C++ programming works. If these things are not clear to you, well, you got to do there some intensive reading and understanding to ramp up to the speed. Okay, let's go ahead and understand this, how these things work, because no answer is good to just memorize. And if you understand everything, literally, you don't need to memorize most of the thing. So understanding is something that will last with you longer than just memorizing things. You would forget the things that you memorize in next 10 days, next 1 month, depending upon memory, but definitely in next 1 year. But if you understand something, then you can always look back to that understanding and you wouldn't go wrong with understanding the concept. So let's understand this. Let's see that, let's say, or let's visualize that this is your memory. Not your memory, but your system's memory or the computer's memory. Now, in this memory, we have two classes, right, for this program. That's class A and class B. Both these classes have a function called print within them. And then we have two objects, at least to the printed program for our initial first case. We have object 1 that points to class A, and we have object 2 that points to class B. So to answer our first question, is this allowed to have two different classes in a same program to have member functions of the same name? Is it allowed? Yes, it's allowed. Why? Because as you see over here in this memory, the different classes like class A and class B is located on different actual space. So the addresses, memory addresses that corresponds to store this class A is different from the memory addresses that corresponds to store class B. And that's why it doesn't matter if the functions within this memory addresses, they have same name, because in spite of them having same name, they have different addresses, and that's what it matters to us. If they have different addresses, then whatever different we do within these functions, the only one thing difference that we do is here we print hello from A, and then second one we print hello from B. But you might be doing more different things in a more realistic example. This is just a sample for you to understand. But that's okay, because this memory addresses are different. You can do anything that's different, and you will be able to trace back to that different things using this different objects. So object 1 and object 2. So if you run this program, then it will print hello from A, and then it will print hello from B. But if we have something like this, something like having, let's see if I can, nope. Okay, let's just continue with this, sorry. So let's say that if we have two objects, those are of same name with something like this I showed over here, then this is a violation. Why? Because the scope of the member function is within the class, right? But the scope of the objects is your whole memory. So if you have two objects that are of same name, that means they are allocated some same memory space in your memory. And because it's the single address space that both of these refers to, they cannot do different things. They need to do one thing because it's only same space that they got. So if we say object 1, do one thing. If we have another object pointing to the same space, then that, in spite of saying it or not, it has automatically done that, because that address space in the memory is already changed. And that's the reason, though different classes in a program can have member functions of same name but doing different activities, but the objects of different classes cannot have same name. This is very important to understand, and many people do mistakes in this concept, and that's the whole reason I wanted to give you an example and then explain the concept behind that example and whys behind that example. Okay, so proceeding further, let's see another concept of templates. Now, many of you would be aware of using templates with functions because it's more common. And we also have in C++, your classes can also use templates. So as you might already be aware, the purpose of template is to give you independence from a specific data type. So the purpose of template is having the usability of one thing across different data types. Now, you know that we have different data types like int, double, char, string. All these are various data types that we have. And depending upon what we want to do, we want to use different data types. So sometimes if the input is integers, 10 plus 2, then your operation is, or whatever you are returning, that item is also an int, which is 12. But if the input is floats or double, something like 1.986 plus 3.512, then your result also is a float, right? So if you want this addition function that you write to be applicable to both int and floats, or int and double and floats, then you would declare that, define and declare that function using template. In the same way, even for classes, if you want the things that you're doing within the class to be applicable across multiple data types, then you need to use templates for that. So how do we use templates for a class? Here is a very simple example for that. So there are some rules of using templates. You need to use this keyword template, type name T. This, whatever the type name that you give over here, I've given here T. We will use that. Think of that as your data type. Now T becomes your data type. And usually what you would do is when you declare something, you'll have int a comma b comma c comma x y z, something like that, right? Here, because instead of int, t is our data type, so we are having t first comma second. Then usually, like, this is the common, we have public label, and you have add, what is this? Can anybody recognize what this add empty bracket, empty curly bracket is? What do we call it in C++? It is a default constructor. As I said, constructor as a topic there is no separate chapter in Top textbook, but it comes binded here and there in different examples. So this is what I was talking about. The add over here is a default constructor, and this add over here is a parameterized constructor. So in this parameterized constructor, we are passing two input arguments, TA, TB. Again, use whatever you have as your type name as your data type. And then we are doing something in this. We are saying, okay, first equals to A, second equals to this. And finally, we have a member function in this class called void add members. And that's it. That's the completion of this class. Then we are, this function add members, unlike our previous example, it is not defined in an inline fashion, right? You see here, we are just declaring add numbers, but later, as I said, most of our functions can be defined outside the class, and we need to use scope resolution operator. So here we are defining the function, and this is the scope resolution operator that we are using, where you have add. Again, we need to repeat whenever you are defining a member function of a class that's using template or that's declared using template. You need to repeat some of the mandatory statements, like repeat the template type name T, that statement over here. And then after that, you can have your class. Again, this is something mandatory whenever you are defining the function of the class that's using template. We have an angular bracket, and within that you have whatever data type that you're playing with. So here T represents that data type. And then we are using scope resolution operator, the function name. What this function will do is it is going to see out print results equals to first plus second, right? Because first and second are the variables that we have defined within this function. And that's it. So this is our class. We have an main function over here in the second column, where within the main function, so as you see over here, then you can use this function that you defined in a class for which you use template. So you can say that, hey, now my T represents int. And then if you pass then we are defining an object one. We are using the parameterized constructor for this object, right? Because we are passing two arguments into the object, 10 and 20. And then we are saying that, hey, for object one, which is having two arguments, 10 and 20, give me the results after running add numbers function. So add numbers function will say first as the first argument, second as the second argument. It will add both of this and return the results. So this will now print out 30, and that's an operation done over int. But because we are using template, we have that flexibility of using the same functions and the same class for multiple data types. So we can use exactly the same class and same function even for double data type, where instead of int, we say that, hey, now my capital T is double. And then in our object, we can pass double to that. And as a result, when you do object2.add members, then it is going to print out the result of 1 plus 89, 1.89 plus 8.63. I'm not that, I think somebody would be already having an answer over here, right? If it's a class, then I would expect somebody to shout the answer. So these are some of the things. Again, to recall, function should work for multiple data type, right? That's the function templates for what we use the concept of template for. Even for classes, it's the same concept where class templates are made to use the functionality of that class across different data types. And both class template and function templates are instantiated in the same way. So even if you want to use function template, you have to follow same rules like using this template angular bracket type name T. And then for the function, you would call the function in the same way, where you would say that function name for whatever data type you are using that function at that time for, and then you would pass arguments. So there are many similarities between function template and class template. Overall, you need to be clear with this concept of template, because we will be using concept of template in the future topics when we discuss trees, graphs, and different concepts further in this class. Okay, then let's jump into the constructor. Let's officially define it. What is a constructor? Constructor, as we saw over here in this example, is a special member function to initialize an object. So here we used our object one, object two. These were our objects where we were passing some arguments, and depending on that, what constructor does that belongs to, right? The add. So it was add is a constructor, and depending on how many arguments we pass, it was using it, whichever the default constructor, parameterized constructor. Here for both the cases, we use parameterized constructor. So as if you look at this, it looks like a member function, right? Add looks like a member function, but it's a special member function with a functionality to initialize the object. Most of the classes should have a default constructor. It's just a way of programming good, because in case if you don't pass any argument, by default, what it will call is a default constructor. Constructor, there are some properties of what differentiate it from a member function. That these properties include that it always has a same name as that of the class. A good thing to observe over here for the people who are attentive and are with me, our class name was add and our constructor names were also the same. That's how you differentiate a constructor from a member function. Add numbers is a member function which need not have the same name as a constructor. If it has the same name, then it is a constructor. Constructors are automatically called when an object is declared. So as you see over here for class add, we just declared an object one and we passed an argument to that. So depending upon how many arguments we passed, corresponding constructor was automatically called. We never did this explicitly, did the steps of first equal to A and second equals to B, but still when you call this function add numbers, it knows what is first and what is second, right? Although you are passing just the arguments, you are not explicitly saying that this is first and this is second. It's doing that correlation of arguments with those names of variables within the constructor. So constructor is automatically called when an object of that class is declared. While the functions, you have to call functions explicitly. Like over here, we call this function object one dot add numbers or object two dot add numbers explicitly. And then we have an example. So for our class time 24, we can have a constructor of class time 24. The name is same. We can, and this is parameterized constructor again, because there are two parameters, and we can do similar thing as what we did in our previous example inside this. Then after looking into the constructor, another topic. We are just touching topics at a rapid speed. So keep up with the speed with me. And whenever you feel a requirement that this is something you don't get, either you can just make notes of it so that after you are done watching this module lecture, you can look back to your notes and then read about those concepts again. Or you can just pause the lecture over here. But in case if you pause, then don't forget to revisit the remaining lecture again, because otherwise you'll miss some of the important concepts later, right? So I would prefer the first one, that complete watching this whole lecture at a stretch whenever you have time, and make your notes while you're watching the things that you need to read more about. And then go back and read more about those things after you are done. And definitely read more about is reading something for a second time or reading it more in depth, maybe from different sources, maybe doing multiple Google search, reading something online and looking at multiple examples, but it's not reading your textbook chapters for the first time. I expect you have to do that and everybody will do that. Okay, so the next concept we are going to see is constant. And particularly, we are going to see constant member functions. If you know this concept, you know that somewhere in C++ programs, you see the word const. This word const could appear behind your different functions. And that's when we call it as constant member function. According to the characteristic of constant member function, something that it's restricted from doing. What is that? Constant member function do not, as the name says constant, it has to do with something that, right? What does it don't do? Constant member function do not change any, what it does not change. What does a class have? Data items and member functions. This is a constant member function. So what is the thing that's remaining? Data members. Data members in the object. So if we declare function as a const, if you have this keyword const behind the function, then these constant member function does not change any data members in that object. This gives these couple of statements over here gives an example of constant member function. How does it look like? It could be void write time, because you're writing it, you don't want it to be changed afterwards, changed dynamically or changed by user. And that's where you give it a const type. You can use scope resolution operator. Even with that, it remains the same. It's just that you will have, if you have a scope resolution operator, while you are saying if that function is const, then during the definition of that function using scope resolution operator, you'll have a curly bracket at the end. That's it. If you have a constructor, then you also need to, if you have a constructor, then you also need to have a destructor. We looked at the constructor over here, but we will look into the destructor soon, which is very similar concept, but using some different keywords. But for both constructor and destructors, they cannot be declared as const because of just as its property that they are special member functions to initialize an object. And it's by default, you don't need to, they are automatically called when an object is declared. And that's where you might need to change after they are called, right? You might need to do some operation within them. If you, if a member function is a const, then you cannot change any data members within that, the scope of that object. And that's the reason why it does not make sense to have your constructors as const. So constructors cannot be declared as const. If you do that, you will get some error by your compiler if it's smarter. Or your program wouldn't run, or it would give segmentation fault, or it would end up with some nonsense output. Okay, jump to a next concept, which is passed by reference. Now, this concept of passed by reference also comes hand in hand with passed by value. When you are passing for any function, when you are passing arguments, you have an option. If you can pass these arguments by value, or you can pass these arguments by reference. If you are passing it by reference, then you will be using the parameter ampersand, and for passing it by value, you don't need any parameter, and that's how you identify the difference. So here in this function, in this example over here, we are having my function, and we are passing the argument of my function x by reference. So this is how you use ampersand operator to pass by reference. Then within this function, we are giving some value to this x, and we are printing the value of x from my function is whatever. Then you have the main part of the program where you are initializing a variable x and you are having some value which is different from within whatever it is within the function. And after declaring x and defining it with some value, then you are calling this function my function for this variable x, where x is exactly the argument that you are passing. Finally, you are doing a printout of value of x from main function is something, right? So whenever you execute this program, it's going to print out two statements. One is from within the function. Whenever this function is called, it's going to, your call stack is going to go to this point, right? And then it's going to execute whatever is there in this function. So it's going to print a value of x from my function something. And then again, your call stack is going to come back here. The next statement is this. So your second printout statement on your console will be value of x from main function is something. What do you think the output of this program will be? If you have a console open and compiler open, just type this program and look if what you expect the output to be is that the output. But first, logically, before you jump yourself into typing the program and trying to execute it to know, I want you to logically think and come up with your own suspectation that this program should print this, and then validate it with whatever you type and execute. Okay, I hope most of you have made your own expectations, and um, you should be able to compile and run this program also in any compiler. Um, so you have an answer. Here, let's see what happens, or let's understand what happens. For if we are passing anything by value, then we make a shadow copy of the counter. Or a variable. So when you pass anything by value, it can refer to two different memory address because a shadow copy is made. Visualize your memory as a long string of arrays, in which long array where you can store different items, right? If this is your memory as a long array, then, and it has different address space, like 100, 102, if it's ints, right? 100, and depending if your int is of size 2, if your int is of size 4, then 100, 104, 108, and so on and so forth. So these are your memory addresses. Now, whatever you store in this memory addresses has some name. So let's say our variable x is stored at 104 space when we declare and initialize in main function. So it stores 10 over here. But when you pass by value, it makes a shadow copy. So the shadow copy of x, when you pass it by value, that could be stored at some another memory address, let's say over here. And then inside that function, whatever you do impacts this shadow copy. So if you have passed by value, right? Are we passing by value in this function over here? Come on, everybody should have a chorus answer for this, right? No, we are not, because we are using ampersand operator. But if you would have been passing it by value, in that case, it will make a shadow copy. And whatever you do inside that function, for example, having 50 over here and then printing this value, right? Cout, that will be done at a different address. Then when your call stack comes back to the main function, your pointer comes back over here. And then when you print the thing in the main function, because you made a shadow copy of whatever you were doing within the function when you pass by value, so then it will just come and print back 10. So if you pass by value, then it would have printed 50 and 10. But because you passed by reference, now what happened here is that when you pass by reference, it does not make a shadow copy. So again, if this is your memory, what happened, your variable x in the main function, you said store 10 over here. When you pass by reference, then you didn't make a shadow copy. What you passed was its memory address, which is 104. You said, hey, there is a variable stored at 104 to the function, and this is what I'm passing to you. That's what means passing by reference. So you passed the memory address of the variable to the function. Then what function did is, okay, it took this memory address 104 and it said, okay, this memory address 104 that's labeled as X, that stores 50. So it just rewrote the thing that was stored at that address 104 as 50. And then it printed that, okay, this is what I'm storing. So this printed 50 over here. Now, when you came back to the main function, right, when your call stack came back, at this line of output of the main function, what you said is value of X from main function. When you're printing that, it's printing the value that's stored by this variable X. But because it was passed by reference, the value remains the same because no shadow copy was created. So it will again print 50. This is what happened under the hood behind the answer that you got. Now, sometimes we don't want the shadow copy to be created, right? Because logically, if it's a single variable, then why would a single variable have different values depending on if it's within the function or if it's within the main? So many times we don't want what happened when we pass by value, that thing to happen. And that's the whole reason we would use by passing by reference to ensure that such errors don't happen. Okay, so to summarize passing of variables, there are multiple options. When, in what case, if you pass a variable, a copy is made and it will not change the real object outside the main scope. When we pass it by value, right? When we passed by value, when we saw an example of passing by value, we made a shadow copy. And the value of the real object that was stored in main over here, this was not changed. Whatever was changed was the shadow copy that we made within that function. The second case, when we do not make a copy and the real object is changed outside the main function. That's the case when we pass by reference. This is something like int a, right? When you pass something like this, pass by reference is something like int ampersand a. Well, aren't we done? No, we have third scenario too. Now, smart students should be able to answer this third scenario. we have covered the topic of this third scenario already. We touched and discussed those. In what case no copy is made and we are not allowed to change the real object outside. No copy is made, that would trigger something, right? Some word in your mind. The second keyword is you are not allowed to change. Not allowed to change should trigger another keyword. And then what I'm looking to is something that you combine with the keyword. No copy is made. The keyword that's triggered is reference. You are not allowed to change. The keyword that's triggered is constant member function, right? Intentionally, I left a space before reference. So constant reference, when you pass things by constant reference, that looks like something, you'll have a word for it to be const, you will have the const word. And this is not member function. This is a variable that you are passing as a constant reference. So the word const is before the variable and you are using pass by reference. So definitely you have int ampersand a. So if you pass something like this, where you, if you pass something like this, that means you are using const reference, const keyword signifies you are using constant, and then the ampersand signifies you are using passing it by reference. If you pass something using constant reference, then you are not allowed to change it outside the real object. It will give you an error and no copy is made because it's passed by reference. So in some of the programs, when you see something like this, then you know now what to expect from that variable a. Okay, so if you have any questions on this concept of classes, after reading the textbook, after doing your search and digging and all that, if you still have some particular technical questions, something like what happens if this, what happens in this case, or something like that, for which you are not able to get answer into the resources, textbook, internet, and all that, then we do have office hours every alternate week. You are most welcome to come and participate in one of those office hours. Office hours are held live, so you will have an opportunity to ask questions during office hours and we will sit together and try to find out answer for your questions. Regarding the details of when this office hours are held, you can look into Canvas homepage that will have what's the Zoom link, what's the time, what are the days, all the details about the office hours. So your questions are most welcome in office hours to talk to me.